In this video, we will be going over how to measure angles in both degrees and radians and their conversions. We will also take a look at how to identify coterminal angles. And lastly, we will determine the missing values of a circle, including its arc length, a given angle measure or radius, and finally the area of a particular sector of the circle. For our first problem, we need to convert 3-degree measures into their equivalent value in radians. For the first question, we're given an angle measure of 90 degrees, and we need to convert it to radians. We begin by saying 90 degrees times the conversion between degrees and radians being 2 pi radians is equivalent to 360 degrees. We can then say 90 degrees times 2 pi over 360. 90 degrees times 2 would give us 180 times pi over 360. And this will be equal to pi over 2 radians. Our next question, we're converting negative 266.4 degrees to radians. Same process, multiply by 2 pi radians over 360 degrees. For this one, we're going to need to use our calculator because it's a little bit more difficult. We do negative 266.4 divided by 360, and we get negative 0.74. So we have negative 0.74 times 2 pi, and we've multiplied by 2, we find that we have negative 1.48 pi radians. Our final problem wants us to convert 2016 degrees into radians. Same mathematics, multiply by 2 pi radians over 360 degrees. We once again use our calculator, taking 2016 divided by 360, and we get 5.6 times 2 pi. Multiplying by 2 will give us 11.2 pi radians. For our next set of problems, we need to convert 3 radian measures into their equivalent value in degrees. So we take 4 pi over 9 radians, and we multiply it by, this time, 360 degrees over 2 pi. The pi will cancel out. The 4 can be reduced to 2. And so we get 2 times 360 over 9. We can then simplify the 360 and the 9 by dividing them both by 9 in order to get 40 on top and 1 on bottom. And so our final angle measure will be 80 degrees. The same process may be taken for the next problem. We multiply by 360 degrees over 2 pi. We converse cancel out the 2, the pi, and the 360 degrees can be simplified to 10, and the 36 can be simplified to 1. And so our angle measure is going to be negative, because the negative still remains here, 10 degrees. Finally, we wish to convert 4 radians into its equivalent value in degrees, and so we take 4 multiplied by 360 degrees over 2 pi. The 2 can be canceled and the 4 reduced to a 2, and so we get 720 over pi, and this can be done on your calculator by taking 720 divided by pi, and so we get 229.2 degrees. For our next set of problems, we need to identify both a positive and negative angle that are coterminal with the angles provided. The first angle we are given is negative 55 degrees. In order to identify the positive angle that is coterminal with negative 55 degrees, we can take the 360 degrees, which makes up an entire circle, subtract the 55 degrees that we are trying to identify a coterminal angle with, and when that is done, you'll find that you have an angle measure of 305 degrees. This would be our positive angle that is coterminal with negative 55 degrees. In order to determine the negative angle, we need to go completely around the circle once more in addition to the negative 55 degrees. And so we take the negative 55 with which we started, and we subtract an additional 360 degrees for our entire circle. Doing this will give us an angle of negative 415 degrees. These two angles can be seen to be coterminal by taking a positive x-axis. If we were to move negative 55 degrees, that would be about right here. And so our line is right here. If we were to move 305 degrees in the counterclockwise direction, we would find that we would be coterminal with our initial angle. This measure being negative 55 degrees. This measure being 305 degrees. We were also able to identify the negative angle that was coterminal by going an additional 360 degrees in the clockwise direction around our circle. And so we added 360 degrees to our 55 degree measure in the clockwise direction to find that we had a negative angle of 415 degrees. The same steps may be taken with the second part of this problem, the only difference being that this angle measure is given in radians, and so all of our mathematics needs to be done in radians unless we choose to convert. We start with 10 pi over 18 in order to determine a possible negative angle that is coterminal with this angle. We can take the 2 pi, which makes up a full circle, and subtract from it 10 pi over 18. This can be simplified to 36 pi over 18 minus 10 pi over 18. And so we get an angle measure of 13 over 9 pi. And we need only keep in mind that this was to determine our negative coterminal angle. And so our first angle is at negative 13 pi over 9 radians. Our positive angle, which is coterminal with 10 pi over 18, may be found by adding 2 pi or an entire circle to our initial angle. And so we take 36 pi over 18 and add to it our initial angle of 10 pi over 18. And so we get out a value of 46 pi over 18 radians. For our last set of problems, we've been asked to determine either the arc length, the angle, or the radius that is missing in the diagram, and we also wish to determine the area of the sector that is indicated. The two equations that we will need to solve these are as follows. The arc length of the sector is equal to the angle measure over 2 pi times the circumference of the circle, or 2 pi r. This equation can also be written such that the angle measure is given in degrees, in which case it would be s, or the arc length, equal to, once again, the angle measure, this time over 360 degrees, and once again times 2 pi r for the circumference of the circle. The equation for the area of a sector looks very similar to the equation for the arc length. The equation for the area being area is equal to, once again, the angle measure over 2 pi. The only difference being this time it is multiplied by the area of the circle, pi r squared. If you wish to solve these in degrees, you would write it as area is equal to the angle measure over 360 degrees, once again times the area of the circle. And so we can solve the first equation by saying that 6 for the arc length is equal to the unknown angle over 2 pi multiplied by 2 pi times the given radius of 2. 2 pi and 2 pi cancel, thus we have 6 is equal to our angle measure times 2, and thus our angle measure will be equal to 3 radians. Finding the area of our sector can be done by saying area is equal to, once again, our angle measure, this time we know the value of 3 radians, over 2 pi multiplied by pi times r, which was given as 2 squared. Pi will cancel out, and so we multiply 3 times 2 squared, which is 4. Thus we have 3 times 4 being 12 divided by 2, and so our area is equal to 6. For problem 2, we can set 14 equal to our angle measure, this time in degrees, 195 over 360, times 2 pi times the unknown value r. Solving for r in this equation should give you a value of 4.11. Determination of the area can be done by saying 195 over 360 multiplied once again by pi r squared, and so we have pi times the r, which we just determined as 4.11 squared, and so we get an area measure of 28.8. If any of the distances measured in the circle were given in meters, we know that the area would be in meters squared. And finally, in our last problem, we first wish to determine the arc length being equal to our angle measure of 30 over 360 multiplied by 2 times pi times the radius, which is given as 4. We would then find the arc length to be 2 pi over 3. Solving for the area of our sector can be done by saying area is equal to 30 degrees over 360 multiplied by pi times our r value, once again of 4 squared. Doing this gives us the area of our sector as 4 pi over 3. And thus we have solved for the arc length of our final circle as 2 pi over 3, and the area of the indicated sector as 4 pi over 3. This concludes our video on the measures of angles in degrees and radians and the arc lengths of circles.